Nicky Fox, Nancy Grace Roman Space Telescope Project Manager, Jamie Dunn, and Senior Project Scientist, Julie McEnery. Each of today's participants will provide brief remarks about our progress on the Nancy Grace Roman Space Telescope, and then we will open the floor to questions. If you're joining us online, please press *1 to join the question queue on the phone bridge. With that, Administrator, the floor is yours.
Great, thank you, Bethany. Good afternoon, everybody. As you can see behind me, the impressive Nancy Grace Roman Space Telescope is now fully assembled, has completed testing, and is undergoing the final preparations before it'll be shipped to Kennedy Space Center to soon take its place among America's great observatories alongside Hubble and the James Webb Space Telescope. Now, our team dedicated over a decade of their lives and millions of hours to make this project a reality. Because of their hard work, I have the privilege of announcing today that we are now targeting an early September launch, 8 months ahead of schedule and under budget. To everyone at Goddard and across all our centers, congratulations. I hope each of you take pride in what you've accomplished. Roman's accelerated development is a true success story of what we can achieve when public investment, institutional expertise, and private enterprise come together to take on the near impossible missions that change the world. Unlocking the secrets of the universe and attempting to answer the question, are we alone, is inherent in just about all we do here at NASA. At our recent Ignition event, we made a commitment to pursue gold standard science as quickly as we possibly can, knowing the world is waiting for the headlines that only NASA is capable of making. Today marks a milestone of NASA delivering upon that promise. Roman will investigate dark matter, dark energy, and the structure of the universe itself, and accelerate the future of discovery of potentially habitable planets outside our solar system. Its surveying capabilities are over 1,000 times faster than Hubble and can chart 200 times more sky in a single image. And what would take Hubble 2,000 years to process, Roman can do in a year. The images it captures will be so large there is not a screen in existence large enough to show them. Roman will give the Earth a new atlas of the universe, and I think it's worth pausing for a moment and just think about how really incredible that is. The farther we reach into space, the greater our curiosity to understand the great unknown. So to our workforce and commercial partners making today's rare announcement possible, thank you for bringing us to this moment. For the researchers and scientists that will analyze the data from Roman, your work will soon begin. And for those that built this telescope, let's get ready for what comes next. Thank you, and I'll hand it over now to Dr. Fox.
Thank you so much, Administrator Isaacman. I could not be more excited to be here today in front of this fully stacked and complete Nancy Grace Roman Space Telescope. And doesn't she look beautiful? I mean, honestly, just gorgeous. We're on track, as the Administrator said, to launch early in September. And that is, I can't stop saying it, ahead of schedule and under budget. And I want to give praise again to this incredible team. Team NASA Goddard totally brought it together with all of our partners in industry, in academia, and our international partners. It is an amazing day to see what happens when we come together and work in such an effective way. Since early in 2020, the Roman team has worked almost around the clock to develop and test the spacecraft and the hardware, completing the flagship mission in just 6 years, which is a true testament to the agency's commitment to do science, cutting-edge science, even faster. Their work ethic and their teamwork, in combination with the lessons learned from our long history at NASA of developing space-based flagship observatories, are why we're sitting in such a good spot today, with all eyes on the launch pad about 8 months earlier than we'd actually expected, which is so good. Well done. And this is just the beginning. We want to get more science into space, launch at a faster rate, and increase the pace of discovery as we prepare to launch more cutting-edge missions. The Nancy Grace Roman Space Telescope is a sheer powerhouse. It is literally a speed machine. The speed at which we'll be scanning the sky, delivering vast amounts of data, and returning results will be at an unprecedented rate never done before. Hubble gathered 172 terabytes of data in its first 30 years. Roman will downlink 1.4 terabytes of science data every day. That means it will potentially have about 2,500 terabytes over the course of its 5-year mission, and basically gathering like a hypothetical stack of science papers that would reach up to beyond the moon, maybe even as far as Artemis 2 went. When you apply what Roman will see, we've already confirmed today over about 6,000 planets. Roman will discover tens of thousands of new planets outside our solar system. It will reveal billions of galaxies, thousands of supernovae, and tens of billions of stars. That is extremely exciting, and literally all of the science that we can use to apply and build off our interconnected NASA science portfolio. Roman will help us address the question of how common solar systems like ours actually are, while also literally expanding the human mind to what the universe contains at an astounding rate. Roman isn't just doing Hubble and Webb science faster, however, and I know it's very easy when we focus on the speed, it's doing fundamentally different science that could not be done with either observatory. Together, the 3 missions will complement each other, giving us a more complete picture of the cosmos and advancing our understanding of the universe. When Roman is operating on orbit at the end of this year, it will also be NASA's first major demonstration for achieving one of the goals of the Habitable Worlds Observatory, a concept for the first telescope designed to find like worlds in different, outside our solar system, in different stellar systems, while exploring the broad secrets of the universe. Right now, Roman has the most stable telescope and the absolute best coronagraph that has ever flown in space. The Habitable Worlds Observatory will rely on even more than that, and it is so important to us that we get this coronagraph into space and get that first milestone towards the next mission, because everything we do at NASA Science builds off the successes of what we've done before. I am so proud that Roman will join kind of the arc of past, present, and now future missions as well. And it will definitely open doors to new cosmic pursuits. So again, congratulations to the entire Roman team, again, including our private sector, our academia, and our international partners. This is such an incredible team. I am so proud of them. Go NASA, go Falcon Heavy, go Roman. Jamie.
Thank you. It's tough words to follow, and I'm going to be followed up by even tougher words. So I'm not going to talk about the science because Julie's going to blow your mind with that. But I would like to take this opportunity to expand a little bit about how we did get here, and just take this opportunity to thank our team. As Nicky and the administrator have already mentioned, it is a lot of work. Millions of hours is no exaggeration. That's actual math. We could figure it out exactly, but it's many millions. And this really is a great example of what happens when we as an agency work hand in hand with industry and academia. We work to each other's strengths, and it's really an example of how the result is greater than the sum of all the parts. So the amount of diligence and dedication and commitment to making this happen is really it's really fun to be a part of. And so this team is really proud to have all of you here to come see this. I can't tell you how excited they are when people come. Last week we had Friends and Family Day. We had about 700 people come through, and watching the kids get all excited. You don't get to see spacecraft every day. So I just want to, again, thank everybody that made this possible. For everybody that you see, there's dozens more behind them. It's not just engineers and scientists, it's everybody. It's our financial team, it's our contracts people, it's our CM people, it's everybody, technicians. It's really a great team. And so this has been a wonderful experience. And I'm glad you guys get to be a part of it by coming here and seeing it. We can't wait to launch.
Thank you, Jeremy. Hi, everyone. Current observations hint that our standard model of the universe is incorrect. Roman will be able to confirm these and set us on the path to understanding what's right. We're going to perform a revolutionary census of planets around other stars in our galaxy. We're going to conduct ambitious surveys that will transform and impact every area of astronomy. And we can do all this because Roman's primary instrument combines exquisite performance and sensitivity with an outstanding ability to sweep out large regions of the sky. Previous speakers have mentioned that Roman can survey the sky 1,000 times faster than Hubble. So to put this into context, 1 month of Roman observations would correspond to a century with Hubble. So Nicky mentioned that Roman doesn't do Hubble science faster. Roman will address entirely new, ambitious science questions. So that 1 month of Roman observations could be used to survey our own Milky Way galaxy, uncovering up to half the stars in the galaxy. That would itself result in an astronomical catalogue of objects that is much larger than any that in existence today. And that's with just 1 month of Roman observations. Our main survey will take more than a year. It's huge. If we were to take the single image that is produced from our main survey and try and fully display it with a set of 4K TVs, you'd need more than 500,000 4K TVs. And just to give you a sense of the scale of that, if I was to lay out those 4K TVs, it would cover 45 city blocks. Or to pick something that you actually look at, it would entirely cover El Capitan in Yosemite National Park. I don't suggest we actually cover El Capitan with a set of 4K TVs, but it gives you a sense of the scale. That survey will detect over 2 billion galaxies. And we'll use it to study how the structures in the universe, the stars, the galaxies, the structures of galaxies, grew and evolved. We'll also study how the universe itself has expanded over time. And these are the keys to unlocking the fundamental nature of dark matter, dark energy, and the fabric of the universe itself. Periodically, we'll point towards the center of our own galaxy and monitor hundreds of millions of stars. But we're not going to just image millions of stars. We're going to find a treasure trove of exoplanets, up to 40 times more than are known today. So think of this as the largest census we've ever done of planets in our galaxy. We have a second instrument, the Roman coronagraph. And I think of this as doing magic with physics. We take advantage of the wave properties of light to cancel out the light of a bright star so that we can image faint planets next to it. To do this magic, we have to have an optical system that can adjust itself to maintain sufficient precision. This will be the first time we've had a system in space with this kind of active optics, and it will set us on a path for future observatories to do extraordinary new things. What makes me most excited about Roman is its discovery space. If we have 2 billion galaxies, it means we have 2,000 one in a million objects. We're going to be surveying patches of the sky, going back over and over and over again to find new things that go bump in the night. I very much hope, and in fact expect, that the most exciting science from Roman is going to be the things that we didn't expect, that we couldn't predict, but that will set the new, deep questions for future missions to address. Thank you.
And with that, we will open the floor to questions. If anybody in the room has, well, Jeff, we'll start with you.
Jeff Faust, Space News. Question for the administrator. You and others have emphasized that Roman has come in under budget, ahead of schedule. Roman is still a multi-billion-dollar mission. Is there still room at NASA for large flagship class missions when the agency's science budget is facing a significant budget cut in 2027 and potentially beyond?
Well, Jeff, I certainly understand why the question is coming up. I'll say that you and everybody else who's interested in kind of my views on the budget and how it impacts the agency will have plenty of opportunities to hear about it over the next week, since I'm on the grand hearing testimony tour, in fact, starting tomorrow. Nancy Grace Roman is not the last flagship mission for us. In fact, here at Goddard, we're working on Dragonfly. Goddard is responsible for a lot of the tech maturation associated with the Habitable Worlds Observatory telescope. We've got a number of signature while not necessarily measuring to the flagship spend category that's being worked on at JPL right now, like Skyfall, Moonfall, and others. So science is incredibly important to what we do here, as I mentioned in my remarks. Going out and trying to unlock the secrets of the universe is fundamental to NASA's mission. I expect there'll be plenty of flagship missions in the future.
We'll go back here to this gentleman. We'll start over here and then move through the room. And then also, if you could hand the mic back after asking your question to our mic runner, that'll help us get to the next people.
My question's for the administrator, Jared. There's something online called the Artemis II effect as part of the Kerbal Space Program community. We're all excited about what happened with Artemis II. Kids I've talked to, fifth graders, I talked to 100 of them last week, they're all really excited. So how do we use this telescope to continue that excitement for the young generation?
Yeah, well, I think it starts with listening to some of the great commentary that Julie just said. I mean, I've got 100 questions coming out of just your intro right there. Look, I am thrilled that the world kind of paused for a moment and took notice to Artemis II, and yeah, I think energized the world's interest in space exploration. Human exploration tends to do that at times, but if it's an opportunity to set the stage for other conversations like Nancy Grace Roman is about to do, that's fantastic as well. We put out some great, like a video reel on it today to get people hyped up about it, and won't be long before this telescope is loaded up on a transport and taken down, and then it's, of course, being launched by a Falcon Heavy. That brings a lot of viewers to take interest, where we'll have opportunities there where, Julie, I sure hope that you're on the live stream for that mission launch to get people excited about the kind of science this mission's going to undertake. So this is great. This is working really well. We're thrilled that Artemis II brought a big audience back to NASA, and now we're going to fill it up with a lot of exciting missions to come. Nancy Grace Roman's next up. I'm going to hand this off so somebody else can
go right
answer.
here.
Hi, Nick Alexander for Space Scout. You know, Goddard has a long history with telescopes. We've, seen some great work on Hubble. We've seen the James Webb Space Telescope come out of Goddard. What can we do to ensure that legacy, that culture of telescopes continues to be centered at Goddard Space Flight Center?
So I think, that's where our expertise is. I mean, at NASA Science, Goddard is kind of the heart of NASA Science, and certainly we look to Goddard to lead the way in a lot of our big missions. They clearly have the heart of astrophysics here. They are, doing a fantastic job clearly with this. The project office for the Tech Maturation Program for Hab Worlds is at Goddard, and we expect that to continue and expect to see them continue to do great things.
We can go right here.
Sorry, Jared, I'm going to hit you up again. So you're the new administrator, and you have this mission that you may have heard is under budget and on time. What lessons can you take away from this? And kind of a corollary is this mission has an interesting history where the optics came from originally. Are people going to just take that and say, no wonder it came in under budget? Or
So I'm going to stick to the first part of the question and say that I'm thrilled that this mission is getting close to its ability to launch, so that we can take Jamie here and apply him to a number of other exciting projects. His name, I mentioned when we had a chance to shake hands in the warm up to this, that your name is continuing to come up quite a bit as an extremely talented project manager. So, yes, look, I think that's actually very important, because we do have success stories like Nancy Grace Roman coming in ahead of schedule and under budget. We certainly have programs or examples that are not. And when you think about that, and you think about going over budget, or in some cases, extremely unfortunate cases where programs are canceled, there are dollars lost from that never come back. And when you total them up, what does that equal? It equals another Nancy Grace Roman telescope, or maybe a second Dragonfly for that matter on that. So I think that having the capturing good lessons learned, we talk about debriefs a lot when we get things wrong to avoid repeating them. But when we get things right and have success stories like Nancy Grace Roman, let's learn from some of the magic that created that outcome and try and apply it to other programs. And I expect Jamie's going to be in big demand across big agency initiatives going forward.
the second part of that question.
Can you repeat the question?
So you got the optics from another agency. Or somebody going to say, hey, no wonder it came in under budget?
Someone might say that, but they'd be wrong. Seriously, so it's difficult. It's one of these things. It's difficult to prove a negative. So who knows, right? It's a different beast when you start with something that you have to completely remodel, if you will, versus starting from scratch. Honestly, it's anybody's guess which one comes out ahead. But that posed its own challenges. It did not make it easy. And I'll reiterate that while I appreciate the accolades, and I'm the person sitting here, I only had a very small part to do with this. It's really our team. We have a wonderful team. We've done a good job of bringing both the experience base from the literally decades of experience here at Goddard, and again with our partners. I mean, we've worked with Ball and L3 Harris on many missions. And others, right? Teledyne, can keep going down the list. And so we really have, part of the magic, I think, is a really good mix of that experience brought forward over decades combined with what you would call youthful exuberance. We have a lot of fresh blood that's come in, and they have just knocked it out of the park. So it's really a good mix of folks that makes this happen.
Hi, Elisha Sowers from Mashable. I think this is a question probably for Julie, Nikki. I'm wondering, could you give a practical example of how the flagship telescopes will work together on particular observations? Could you give us an example?
There was a really cool result from Hubble, I think about a year, maybe 2 years ago, where what they thought they were seeing was a supermassive black hole that was traveling through space. And you could see from the observations the evidence of that transit. And it was extraordinarily lucky that Hubble was able to catch that. Roman would be able to find some things like that in spades because we're surveying such a large part of the sky. And then we can follow up with detailed measurements with the James Webb Space Telescope now that we know where to look. So you could consider one of Roman's roles to be something like a finding chart for the James Webb Space Telescope, that we'll find some of the most extraordinary, unique places in the universe, and then we can direct our most powerful scopes to really hone in on the details and take advantage of Roman's breadth and Hubble's depth.
I can move back here.
I would have gone into wavelength, and that's nowhere near as good as what you said.
Excuse me. I just wanted to say congratulations on an awesome first 4 months of 2026. When you go across, whether it's Science Directorate, obviously Artemis, it's been unbelievable. So with regard specifically to Roman, though, we had an announcement, Jared, on the launch date. I wonder if there are any promotional announcements coming for the people involved in the project?
Sorry, when you're saying promote.
I would assume I'm wondering who's getting promoted for delivering ahead of schedule and under budget.
Yeah. So that's a very good and serious question, because as I mentioned before, we do want to debrief our success stories and learn from them and take those lessons and apply them elsewhere. And also I think it actually was my first directive that I put out, which was, recognize, reward, and inspire the top tier talent within the agency when you do have extraordinary outcomes. So I would expect, to your point, that will certainly come into play here.
We'll move to Will.
Hi, Will Robinson-Smith with Spaceflight Now. Thanking you all for the time today. Going back to, Julie, your opening remarks, something you said caught my ear, which is there's things that we got wrong about our understanding of the galaxy and the universe. I know, based on everything that we've heard today from the panel and from others, We're going to learn a lot more from Roman, but what specifically did we get wrong that this can correct the record on? Thank you.
I'm just trying to think about how to say this concisely. So we have a extraordinarily good model of how the universe works that describes the cosmic microwave background at the earliest times and describes with great accuracy the universe that we live in today. And that's included things like the Hubble constant. It's included things like a cosmological constant for dark energy. It's included the concept and the effect of dark matter on the universe that we live in. But there's been cracks. We're seeing evidence that the Hubble constant, as inferred from very early times, is not consistent with the Hubble constant that we measure closer to now, which is telling us that the model that connects those two things might not be quite right. We have a slight tension in our expectations for how structure should grow and evolve. And excitingly, recently, we've seen evidence that the cosmological constant might in fact not be constant and might be varying with time. And each one of those results is not quite by itself enough to take it to the bank and say that we're wrong. And what you need is a mission that can, or an experiment that can probe the universe to about a factor of 10 better than we did before. And that will allow us to confirm if indeed lambda CDM, our standard model, isn't correct. And will leave us with a mission that has the sensitivity and the performance to make the kinds of observations that we need to start laying out what the real answer might be, or what an improved model might be.
We'll move up here.
Hi, I'm Anisha Ravasetti with Space.com. I have maybe a bit of a peculiar question, and it's an engineering question, but you can chime in. I feel like often when creating, space missions, observatories, you're kind of breaking ground in like the materials you're using, the temperatures that you're testing at, and there tends to be these like side effects of like innovation that other fields of science can like take advantage of. So did you find any examples of this during your process?
I mean, who wants to answer it? Go.
So you're right, and I think that with our astrophysics missions, we really do push the boundaries of what's been done before. Every time we do new precision optics, I mentioned this is the most stable telescope. It has the most cutting-edge coronagraph. It has precision optics. If you just think about the James Webb Space Telescope, that brought about like the actual grinding of the mirrors. The polishing of the mirrors, not grinding. Sorry, astrophysicists, polishing of the mirrors. Brought about leaps in medicine, in optics, in LASIK. I mean, all of the things there. With Roman, we expect to see the same things. Can I tell you right now what's going to spin off? No. But the way that this telescope is constructed, the precision optics, the stability is absolutely, once again, going to push industry, and things that they've had to design and they've had to change their methods to be able to get to this level actually benefits everybody, because now the whole optics field has improved dramatically.
Move over here.
Hi, I'm Marina Corn with National Geographic. I think this question is for either the administrator or Dr. Fox or both. Looking ahead to the next big space telescope, the Habitable World Observatory, we heard from the team today that they're going to be spending the next few years looking at the mission concept and seeing if they can make happen an $11 billion mission by 2045 launch. If they come to you and say, we can't do that, what's the next step? How do you go about making that mission happen?
So I think, the way we are thinking about habitable worlds, I mean, somebody mentioned about, what made Nancy Grace Roman such a success. And a lot of it is making sure that the technology is ready to go. So before you actually start sprinting with a mission, you've actually assured that you can do the mission. And so with Habitable Worlds, we're putting a lot of focus right now on maturing the technology. We've got a lot of our industry partners actually working on that right now. There's a big milestone in 2028 when we will actually sort of step back and look and say, is this mission possible? If the mission is possible, we will sprint to do the mission, and it will not be 2045, and it will not be $11 billion. We will put a real budget and a real schedule. As the administrator said several times, we're not interested in doing something now that's going to launch in the 2040s. We want to pull that in, and I think with the new focus on doing things, faster to science, faster to space. Our industry partners have told us that they are, I'm looking at them, they are up to this challenge, and they are excited about doing this. And they don't want to wait till 2045 to launch this mission either. We didn't want to wait to launch the Nancy Grace Roman. We're 8 months ahead of schedule. I'm going to say that like 20 times. But we are, we can't wait to launch this mission. Everybody felt the urgency. Everybody was sprinting towards this. And I think that, now we've shown we can do it. We have a large mission study that we did at NASA where we looked across the entire space portfolio and looked at lessons learned. What worked, what didn't work? What do you need to do? What shouldn't you do? What are the barriers? What are the impediments? And we are really, really, really focused on removing those and allowing teams to just push and execute. And so honestly, if a team comes to me and says, in 2028, it's 2045 and this much budget, then they won't be getting funded.
Just add on a bit. It's a good question. This has come up a lot in various circles that I've had conversations with, including Congress, those on the side that are extremely supportive of initiative like Habitable Worlds, and others that get concerned based on pretty much everything you just said. It's a mission that's going to launch potentially 20 years from now, and it's $10+ billion. And I fear at times that this isn't necessarily specific to Habitable Worlds, but maybe within some history of NASA, that we design programs that are too big to fail, but then they become too costly to truly succeed. And I don't think that's the right approach. And maybe it's believed that taking that approach is a way to have continuity and survive between administrations. And I actually think the right way to go about it, and similar to what we're trying to do now with the moon base, is a lot of littles, and to do things in an iterative way, to learn and bring down risk. And maybe, as a result, the overall project cost in itself could wind up being more. But what you get out of it is greater, and you do it in a faster way. So any commentary I've ever made with respect to Habitable Worlds is what can we launch sooner to learn and help us get to the overall objective of what Habitable Worlds is, which is extraordinary and something everybody would want. And in that respect, if it turned out over that same 20-year period of time, the actual program cost was greater than, say, $10 billion, but included 3 scientific instruments that ultimately built up to the grand exploration asset that we hope Habitable Worlds to be. I think that's how you actually have continuity through administrations, how you get to data faster, and ultimately de-risk the mega telescope that you want out there searching for Habitable Worlds.
We're going to move over to the phone bridge for just a moment and start with Nell Greenfield-Boyce from NPR.
Having this briefing. You mentioned the numbers of extrasolar planets that the Roman Space Telescope will be able to find. Could you talk a little bit more about what about the planets this telescope could reveal, like particularly with its direct imaging capabilities? Thank you.
Okay, so when I was talking about the large number of planets that we would find, I was focusing on the planets that we find via indirect means. And for that, we can measure things like masses and radius of the planet from the host star. So that will give us a complete picture of the distribution of planets around stars from very close in to the star all the way to the equivalent of the outer part of our solar system, and even free-floating planets. The Roman coronagraph is designed as a technology demonstration. So its primary purpose is to demonstrate the technologies needed for a future mission to focus on direct measurements of extrasolar planets. obviously, the best way of demonstrating performance for a coronagraph on a path to finding planets around other stars is to find planets around other stars with that coronagraph. But the overall performance is a little bit more uncertain, and I'm not that familiar with the specifics of what we are guaranteed to learn from observations with our coronagraph, just that it's very exciting.
And we'll now move to Manuel Mazzanti with Exploración Espacial.
Thank you so much, Manuel Mazzanti with Exploración Espacial. Roman is going to send us tons of information. Nicky, I think you mentioned 1.4 terabytes per day. And I understand that the agency is going to use a platform called Roman Research Nexus. Can someone briefly explain how does it work? And I'm assuming research around the world, scientists will have access to it. And is NASA going to use any kind of AI tool or software that would help scientists to better process all this information? Thank you.
Okay, there is a lot in those questions. The data archive for Roman is among the largest in space-based astrophysics and requires a slightly different approach to using it. So our model is that we archive the data in the cloud and people access the data through a science platform. So you log into the science platform, you're in a Roman-specific environment, it's easy to access the data, it's easy to visualize the data, it's easy to use the data. And that facility is open to everybody. So for the earlier question on how can young people get excited about Roman, you can get excited about Roman by being on the forefront. A class in Kentucky can see Roman data at the same time as a professor in Princeton. And your access to that data is through the Roman Research Nexus. That same environment also supports researchers all across the country, where we're working hard to facilitate easy, quick access to the data, where you're not wasting time downloading things and then discovering that that the CPU on your laptop wasn't sufficient to do anything with it. So the second part of your question